the water district is reviewing 24 water bottles. Of those water bottles, 6 have toxic chemicals in the water. Man, that sounds like a lot. What is the probability that the water district chooses 3 water bottles and none have toxic chemicals? So that independence rule that we looked at before, that applies to more than 2 events too. Yeah, so let's here the probability of that all 3 are non-toxic. None have toxic chemicals. So what's the probability that 1 is non-toxic? That probability is, let's see, if 6 are toxic, then 18 are non-toxic. So there's an 18 out of 24 chance that we randomly select 1 water bottle and it's non-toxic. Now, the probability that the next one is non-toxic, I'm going to carry down this for just a second and multiply. It's 17 out of 23 because we've already selected one of the 24 water bottles. Now there's only 23 more to pick from. And we've already picked one of our water bottles in our hands is one of the non-toxic ones. So now there's only 17 non-toxic ones. And then there were 16 non-toxic ones. And then for the same reason, there's 22 left. It's supposed to round to the nearest thousandth, so that'll be nice. We can change to a decimal at the end. All we have to do now is the fraction work. 18 times 17 times 16. 4896. And then we got 24 times 23 times 22. That makes 12,144. And as a decimal to the nearest thousandth, that's 0.403. That's the probability that you pick 3 water bottles and none of them have toxic chemicals. There are 43 milk jugs in a refrigerator with 11 jugs being spoiled. So if you this sounds really similar. If you randomly choose 5 jugs, what's the probability that the first 2 are good and the last 3 are spoiled? It is a little different. So what's the probability that you just pick 1 and it's good? The first one, it's the probability that you pick it and it's good. Well, if there's 11 spoiled, then there's 32 are good. Right, so the probability that the first one is good, it's a 32 out of 43 chance. There's 32 jugs, 32 jugs that are good out of a total of 43 jugs to pick from. Now that's the first one. They say the first 2 are good. So for the same reason on the last one, we're going to reduce each by 1. Now there's 31 that are good because we already have 1 good jug in our hand. And there's 42 that are bad because we took one of the jugs out of the pile. And the last 3 are spoiled. Well, there's still 11 jugs that are spoiled. We haven't picked any of them. But now there's only 41 jugs to pick from because we subtracted a jug out when we took the second one. We're down to 41 jugs because we keep picking more. And then there's 10 out of 40. And then there's 9 out of 39. Oh, man, they want this one as a fraction? That's nuts. That's crazy. I hate that. Look, we can simplify this. 10 out of 40, that's 1/4. Oh, I don't know. Like, this is huge. You'd have to sit there forever to think if you could reduce it. 32 times 31 times 11 times 9, that's 98,208. And then the denominators, multiply all the denominators. I'm just going to hope that we don't have to simplify. 43 times 42 times 41 times 4, right, because we reduced this one, times 39. 11,000. That's nuts. Why did they make the last one a decimal and this one you have to have the fraction? They're both even, so we're going to be able to reduce it. So let's go use technology. In Google, I'm going to search fraction reducer calculator. I'm not going to burn the years of my life trying to figure out that one. 98,208, and then this one down here is 11551,176. If I typed it in right. Yeah, everybody knows. Why didn't I realize this? I should have known. Of course, it simplifies to 1,364 over 160,433. Let's type that in, see if See if we get what they're looking for. 1,364. I was mad when I wrote that. It's all over the place. 160,433. Yep, that's it. What are they trying to test? So you can do that. Google search fraction reducer calculator in case it's a huge fraction like that, okay?